All right, so continuation of Lesson P.4. All right, I think we're on example 8. If I'm correct, does someone want to verify that from their notes on Friday? Yes? Okay, thank you. All right, so we're going to graph on a calculator. And find the zeros and point of intersection. Okay, first equation is y equals 2/5 x minus 3. And the second one is 2x plus 3y equals 6. Okay, so everybody take their graphing calculator. Is there anyone who has not graphed on a graphing calculator at all? Okay. All right, so on our calculator, we're going to go to that top left button that says y equals. Good. Okay. All right, so we're going to go to y equals. If you have anything on there, just clear it out. Okay, so you can do fractions one of two ways. You could put 2 divided by 5 in parentheses, or you do have a fraction key. It's just not on the plate of the calculator. We have to find it using alpha y equals. So alpha y equals should get you this little fraction menu that pops up. Okay, so I'm going to use that numerator over denominator. And then I'll type in my 2/5 x subtract 3. Okay, now this equation is not ready for the calculator yet. I have to solve this for y. There's no way to enter a line in this form. I need to put it in y equals form. So first thing I'm going to do is move that 2x over to the other side. You don't have to put the 2x in front of the 6. I'm just used to using that slope-intercept form. Okay, I have to divide everything by 3. So I get y equals negative 2/3 x plus 2. Now it's ready for the calculator. So on my second equation, I'm using negative alpha y equals, gets you that fraction, 2 over 3 x plus 2. Anybody need help? Slow down, back up, explain something. Okay, so if you push that magical graph button here, you may get a graph of these two equations. I will not, because I set my window on something really wonky last block. So I'm going to push graph. Okay, can't see it. As soon as this stops moving. Okay, now a good way to just sort of square up your screen and go to your 10s and negative 10s, if it has been changed, is go to Zoom Standard or Zoom 6. And that goes back to your domain and range of 10 to negative 10. Okay, so does everybody have a graph that looks like this? Walker, you need help? Okay. Do you have the equations like this? Okay, so go back to what I asked in the problem. What does it mean find the zeros? X-intercepts. Okay, so zeros are x-intercepts. Okay, and the calculator will do that for us. Like, what more could we ask for? Okay, so let's go back to our graph. Let's take this line that's kind of like the upper line here, and I'm going to find the zero for that. Okay, so what I'm going to do is go to second trace, and that has a lot of things that we'll use, including the second option is 0. Okay, so I want to find the 0. Okay, well notice, is your cursor flashing on the bottom line also? Okay, we'll just stick with this line first then. Okay, so notice it's asking me a question at the bottom. It's saying left bound. Okay, so graphs can cross the x-axis multiple times, right? That doesn't make it not a function. So it knows this. So it's wanting us to zero in on exactly where this x-intercept is. Okay, the x-intercept for this line is over here. Okay, what I'm going to do is just move this cursor just a little bit closer in using my right arrow. I'm just going to sort of scoot past that other line. Okay, so as long as your cursor is still blinking to the left of the 0, push enter. Now it's asking me another question. Is this a right bound? No, this cursor is not to the right of the 0. So I'm going to move the cursor, until you know it is clearly to the right of that 0. Push enter again. And it's saying yes. No, I never want to guess. I want to push the enter one more time, and it will go directly to the 0, aka x-intercept. Okay, so the 0 for this function is at 7.5. So 0 x equals 7.5. That is for this line here. Okay, let's go ahead and find the 0 for the other one. So same process, go to second trace, so you get that calculate menu. I want a 0. Okay, it's still on the line that I had. So if you will push the up arrow, it should shift to the other line. Okay, now you notice that it's blinking here. And it's asking me, is this a left boundary? No, it's not. So I've got to move the cursor backwards, or up the line, until it is clearly left of the 0 I'm looking for. Then I'm going to push enter. Now it's asking me, is this a right boundary? No, it's not. So I'm going to move that cursor until it is to the right of that 0. Then I'm going to push enter. I do not want to guess. If you'll notice too, I forgot to say this last time, see these two little arrows at the top? That tells you, okay, the calculator's only going to look for an x-intercept between those two domain values. Okay, so push enter one more time. And there we go. This 0 is at x equals 3. Okay, so you could write the 0 as an ordered pair, 3, 0, or just say the 0 is at x equals 3. And the reason these are called zeros, it's where the y value is 0. So that's why it's called the 0 of the function. Okay, any questions on finding those? Okay, so now we want to find the point of intersection. Point of intersection. Now, this will be an ordered pair. I'll need an X and a Y. So we'll go back to that same menu. Second trace gets us back to that calculate menu. And you'll notice that number 5 says intersect. So push 5. Okay, now remember when you go to Y equals, you can enter like 8 equations. And I could find any combination of points of intersection. So this is why it's asking me, is this the first curve? Like, is this one of the equations that you're interested in the point of intersection on? And it is, so we just push enter. Is this the second equation? Yes, push enter. I still don't want to guess. Push enter again, and it should go to that point of intersection. So when you're looking for point of intersection, you don't have to use the left and the right boundary concept. So you basically just go enter, 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 and it goes straight to your point of intersection. So this will write as an ordered pair of 4.688, I'm going to round that to, comma, negative 1.125. Give me at least a couple decimals is usually a general rule. For those of you who take AP Calc, our rule is 3 decimals, minimum of 3. Okay, any questions on that? So the calculator can do all sorts of useful things for us. How would I find this point without using the calculator? What would I have to do? I can graph it, but look at this point of intersection. Like, even if I used graph paper, would I ever approximate that number? No. So if I wanted to find the exact point, what I could do is substitution or elimination and go that route. But looking at this funky number that we got, I would guess that might be a little messy process. But that's how I would do it algebraically. I would use substitution or elimination. Okay? All right, so next one, we're not really going to use our calculator for this one. Still dealing with lines. This time we are going to write an equation of a line through 1, negative 2, that is A, parallel, and B, perpendicular to this other line, 3x minus 2y equals 1. Okay, so write an equation of a line through the ordered pair 1, negative 2 that is parallel, and then another one that is perpendicular to the line 3x minus 2y equals 1. Okay, we need to remember a couple things about parallel and perpendicular slopes. Tell me what parallel lines have in common. Yes. Same slope. Do they have any points of intersection? No. So they share no points, but they do share a slope. Okay, so parallel, and I'm just going to draw it like this. Parallel lines. That's a little symbol. Oh, y'all can't really see that, can you? Let's pick a new color. Okay, this is a little symbol that means parallel. So parallel lines have the same slope. So equal slopes. Okay, tell me what is true about perpendicular lines. Anybody? Yes. Okay, and how are they related to each other, like visually? Yes, they form right angles. Okay, so they intersect at 90-degree angles. Here's a little symbol that we use for perpendicular, because Lord help us, none of us can spell perpendicular on the test. Just trust me on that one. I get the strangest spellings. So perpendicular lines have slopes that are negative reciprocals of each other. Okay, sometimes you'll hear people say negative reciprocals, sometimes you'll say opposite reciprocals, but they are flipped if you're talking about in fraction form. One is positive, one is negative. Okay, so let's go back to our problem here. I have this line. That's not the line I'm writing. I'm writing an equation that is parallel and then perpendicular to this line, but my line needs to go through this point right here. Okay, what do I need to know first? y equals mx plus b. Okay, I would put this one in y equals mx plus b. What information do I need from this line? What is your slope? Excuse me, but what is your slope? I need to know that so that I can use the same slope here and then the negative reciprocal slope here. Okay, so let's rewrite this equation. I had 3x minus 2y equals 1. And I want to solve it for y. So let's subtract 3x. I have negative 2y equals negative 3x plus 1. And then everything gets divided by negative 2. So that I get y equals positive 3/2 x minus 1/2. Everybody okay with that? Okay, the only thing I care about is this number right here. That is the slope of that line. I am not going to use this y-intercept at all. Abandon that. Jump ship, take 3/2 with you, that's it. Okay? All right, so let's do part A. Let's find this parallel line. Okay, so I know that the slope is 3/2, and I know that my line goes through this point, 1, -2. How would you write that equation? Would you do y equals mx plus b or point slope? Okay, you pick whichever one you want. I think I'm going to start with point slope, but that doesn't make it the right way. So I'm going to do y minus y1, so that becomes y plus 2 equals the slope times x minus 1. Or use y equals mx plus b. Now, if I didn't care what form this equation was written in, I could stop there. Okay, but so that I match up with those of you using y equals mx plus b, I'm going to keep going. Then I'm going to subtract 2. And I'm going to get y equals 3/2 x. Let's see, that's minus 7/2. Correct me if I am wrong there. Okay, or if I don't specify what form to leave it in, you could leave it as that. Either one of those would do. Okay, so this line had a slope of 3/2. Parallel line has a slope of 3/2. Everybody good with that? Okay, let's do part B, where I am finding the perpendicular line. So what is the slope going to be now? -2/3. So that is my slope. Slope is -2/3, and it still goes through the point 1, -2. Okay, so either use y equals mx plus b, or use point slope. Okay, if we're leaving it in point slope, voila, we're done. But if you were using slope intercept, and then I would subtract 2, and I would get y equals -2/3 x, -6, -4/3. Either way would be fine. Question. Okay, so everybody, when you are doing a problem like this, once you solve this one for y equals the equation I gave you, you are not going to use that y-intercept again, right? This is not your y-intercept. It's the y-coordinate of that ordered pair, but that is not on the y-axis. Those are the two common mistakes that I see with those types of problems. Okay, next. Okay, we are going to do everyone's favorite, a word problem. I think I have two more big examples here. Okay, example 10. Camelot Apartments. Bless you. Purchased a $50,000 building and depreciates it $2,000 per year over a 25-year period. A, write a linear equation giving the value y of the building in terms of the years X after the purchase. Write a linear equation giving the value y of the building in terms of the years X after the purchase. Okay, so I think on this one I would start or use y equals mx plus b. Because I have an initial value, so that graphically we'll interpret it as a y-intercept. Okay, so let's talk about this word depreciates. What does that mean? Something depreciates, loses value. Okay, so in terms of this situation, and I want to write a linear equation, what would my slope be? Yeah, that depreciation value, because every year that value is dropping $2,000. So that translates into our slope. And I would definitely use a negative here because it's depreciating, not appreciating. So if it was gaining value, I'd use a positive M. Depreciating, I would use a negative. Okay, do I know the initial value of this building when I got it? Yeah, that's $50,000. Graphically, what will that interpret to? Y-intercept. It's the value when time is 0. So that y-intercept will be a positive $50,000. Okay, well, if I already know the slope and I know the y-intercept, I can jump right into the equation of the line. That's going to be negative 2,000x plus 50,000. Okay, so there's my linear equation. Easy enough. Okay, part B, in how many years will the value be $24,500? In how many years will the value of the building be $24,500? Okay, am I giving you X or Y here? Yeah, Y is the value of the building. That's what the whole explanation above said. The value of the building is Y. So this means I'm using this equation, but I'm supplying Y, and I want you to find X. X is the time in years. So if 24,500 equals negative 2,000x plus 50,000, then I'm asking you to just solve for X. Find time. Okay, what would you do first? Subtract the 50,000. Okay, so that's going to be 25,500 equals negative 2, oops, I left off my negative, 2,000x. And then I will have to divide by negative 2,000. And we're going to grab that calculator and divide. What'd you get? 12.75. What if I got a negative here? Would that be okay? No, this is time. It's number of years. So I should expect a positive answer. How many months is 0.75 years? 9 months. Okay. Question? So you could also say 12 years, 9 months. Are we good? Okay, one more example. It also has 2 parts like this. Example 11. Okay, I'm going to give you a table of information. You can call it data or data. Both would be correct. I tend to say data, but either one's okay. Okay, clearly this is not going to represent individual income, right? Because it's in trillions of dollars. I don't really know anyone who makes trillions of dollars per year. So this is like total, add up everybody's income, and this is what we have. Okay, so 2 different columns, the year and then what the income is. And again, that's total in trillions of dollars. Okay, we're going to start with 2002. And go up to 2007. Okay, the income, 8.9, 9.2, 9.7, 10.3, 11, and 11.7. Do you think this would be exactly linear? I mean, as the years increase, these increase, but are they increasing at the same amount? No. I mean, a few of them are, like that goes up by 0.7, that goes up by 0.7, but not all of them do. So it's a situation that is closely linear, but not exactly linear. Okay, so if I said pick 2 points and find a line between them, would we all come up with the same line? No. They might be similar, but they would definitely differ if we chose different points. So I'm going to tell you the points that we're all going to use just so that we are getting the same one. And we're just going to use the first and the last. So 2002, 8.9, and 2007, 11.7, to write a linear equation for the data. Okay, so we're going to use these specific ordered pairs and write an equation of a line, y equals mx plus b, or we can do point slope form. But either way, what do I need to know first? Yeah, what is the slope? So whichever form you're going to use for the line, we've got to find the slope by using slope formula first. Okay, so that's y2 minus y1 over x2 minus x1. Okay, get me a decimal for that slope. Let's see if we all come up with the same thing. Okay, when you get a slope, check up here. See if you got the same thing. If I were to put units with this slope, what would the units be? Trillions of dollars per year. Because what did I subtract up here? The trillions of dollars. And on the bottom, I subtracted years. So this would be trillions of dollars per year. Per in math really means divided by. Okay, so that would be what that slope is representing. Okay, but I still haven't written the equation of the line. Let's all use point slope, but which point do I use? It doesn't matter. It doesn't matter. We can use either one and it will represent the same line. Okay, I'm just going to stick with the first one. So I'm going to say y minus 8.9 equals m times x minus 2002. All right, let's distribute on the right. So I get 0.56x minus 0.56 times 2002, 1121.12. And then I'm going to add that 8.9 to both sides. So I get y equals 0.56x minus 1130.02. Did I add that right? 12 plus 8.9. Okay. 1130.02. Okay, so that would be the equation that would represent this. Pardon me? Yes. Thank you. Alrighty. Then we're going to use our equation to estimate. Yes. It's not. Well, it's weird because I had a different number on my paper, but I don't see what I.
Oh, it's because you added.
Did I type something in wrong?
You probably put negative 8.9.
I didn't. I added it on my paper. What do y'all have? Oh, I didn't have this negative at first. Yes. Okay. Okay, that was confused because I was looking at my paper that I did last time. I'm like, I definitely got a different answer. Okay. Thank you. Yeah, y'all speak up. All those dumb mistakes that you make, I make them too. So I am not offended or embarrassed if you call them out. Please, call them out. All right, are we all good now? Okay. Now we're going to use that equation to estimate the income in 2005 and 2010. Okay, so how am I going to use the equation to estimate that income? Sub in the year, right? Because X represents the year, Y represents the income. So for 2005, I am subbing in Y equals 0.56 times 2005 minus 1112.22. And let's see what that gives us. 0.56 times 2005 subtract 1112.22. 10.58. So what y'all got? $10.58 trillion. Okay, then let's do the same thing for 2010. I'm not going to write out the substitution. Let me show you something, guys. You may know this already. Hopefully you do. But if I don't want to type that in again, I can arrow up till it's black, push enter, and it like copy paste. And then I just backspace and type in the 10 over the 05. Hopefully you knew that trick to save some time. If you didn't, then there you go. $13.38 trillion. Is there anyone in here who's taken AP Stats? Like right now, or already in the past? Okay. So let me show you, have you ever typed in a table like this into your calculator and had it give you a linear equation? Oh, let's do that real quick. Yes. You're about to go, yeah, don't go right here in front of us. Okay. All right, so go back to the table. This is what we're going to do. The calculator can estimate a linear equation for us. However, it's probably going to be a little bit different than the one we got. But let's see, and maybe they'll match up. Let's see. Okay, so go to the stat button, which is right here. Find your stat. And I want to edit. And you should get lists. Does anybody have lists that have numbers in them already? Nobody? Okay, cool. Okay, if you don't, then we're going to type in list 1, those X values. So those are our years. So let's type in 2002, 2003, 2004, 5, 6. Listen, all those buttons. If my data started with 0, yes. So are you saying like this would be year 2, 3, 4? You could set it up that way.
Ms. Clark told us that for the 2002 it would be 0 and then 1 from there.
Okay, you can do it that way. But then you have to be sure when I say like estimate what it would be in 2010 that you use 10 instead of 2010. Okay. But you can set it up either way. You just have to be consistent with how you enter those years. Okay, list 2. We're going to do it the lazy way and just use the exact values. Okay, so Y goes in L2. Okay, once you get those lists, let's go back to that stat button again. And I'm going to arrow over to calculate. And then I have all these options. Okay, so I want to find an approximation for a line. And that is called a linear regression. So that is number 4, linreg. And it has that AX plus B out to the side, so that kind of lets you know that that's a line. And then this is just saying, okay, we're going to pull X values from list 1. That's exactly what I want. We're going to pull Y values from list 2. That's exactly what I want. So just keep pushing enter until you get this. Okay, so it's telling you at the top, hey, A is the slope and B is the y-intercept here. So I'm going to write down this equation that the calculator gave us, and then we'll see how close or different it is. So calculator's equation would be y equals 0.57x minus 1135, we'll call that 0.30. Okay, now is that one wrong? No. Remember we said this is not an exact line because these differences don't stay consistent throughout each year. So this is not an exact line. This is just a different way of calculating an approximation of that line. But look, those are pretty close, aren't they? I mean, they're not too far off. So that's the calculator's version. This is our version using the first and last ordered pair. Okay? I would say that both are valid approximations that we could use. All right, any questions on that? Okay, so I'm going to come around with your agenda. Let me just take a look at this together with you. All right, so what we are working on today are these problems, and you have about 35 minutes to work on them. So we're working on these problems right here. Notice tomorrow what we are doing. We are taking a quiz on everything that we've done so far. But as I mentioned last week, you may use your notes on the quiz. Okay? Any questions on that? And our first test will be next week, late in the week next week. Okay? All right, let me come around with this. And then you have the rest of the time to work. You're freezing? I can make it a little bit warmer. Pause this video. I'll tell you what, just start here and pass them around.